So, good day everyone. My name is Clark J. Dairo. My report is all about flood control structures. So, these structures or methods are used to reduce or prevent the detrimental effects of floodwaters. Flood relief methods are used to reduce the effects of floodwaters or high water levels. So, flood control structures are necessary to diminish the effects of excess waters in streams. They can be distinguished in structures that provoke a reduction of peak flows and in structures that divert floodwaters through flood bypasses. So sometimes levees can also be used to control flood events. So discuss na to na taod-taod. So flood control structures support urban programs. So kani siya nga mga programs is related to cities and economic growth and trade. So mga farmers sa mga agriculture and more. So food and water availability ang last nga ginasupport sa flood control structures. So mo na siya mga example sa flood control structures. Sa upper left corner nga makita ninyo, ang tawag ani siya kay spurs and dikes. Sa left is flood walls, and sa bottom ay sa right is flood walls, and sa bottom is sea walls. So ano siya, example ni siya sa nagaprotect sa economic trade and growth or agriculture nga flood control structures. So bunding, so made from clay-based soil formed into an embankment to act as a flood barrier, protecting domestic gardens from flooding. So bunds are also known as levees, flood banks, stop banks, earth sound barriers, flood barriers, and embankments. So embankments meaning mga pwede siya soil, pwede siya concrete, pwede po siya mga stones nga gipatong-patong. So types of flood control structures is, first we have flow through dams, flood walls, channels, flood control reservoirs, levees, weirs, and flood or stop gates. So flow through dams. Flow through dams, also known as perforated dams, are constructed solely for the purpose of flood control and mitigation of flood risk in downstream communities and ecosystems. Unlike reservoir dams, which are built primarily for water storage or power generation, the spillway or opening is built at the same height as the riverbed level, allowing the river to continue its natural flow in normal conditions. When water level rise above the spillway, the dam restricts the amount of flowing through the opening, decreasing peak flood flow. Since flow-through dams minimally affect rivers' natural flows, under normal conditions, negative environmental and socio-economic impacts, such as sediment accumulation, restriction of water flow to downstream communities and ecosystems, and breaching during very extreme flood events, can be minimized or avoided altogether. So kaning nga mga dams gina-control niya ang flow nga mugawas gikan sa reservoir. So ginapagamay niya, gina-restrict niya para makakope ang nasa downstream nga mga cities or village or towns. So mo to siya. So mo ni siya picture sa flow through dams. As you can see in the left nga kanang ang water level sa river kay dito po nagagawas ang tubig sa dam, ay dito po nagapagawas og tubig ang dam. So flood walls. Flood wall is a primarily vertical artificial barrier designed to temporarily contain the waters of a river or other waterway which may rise to unusual levels during seasonal or extreme weather events. So flood walls are mainly used on location where space is scarce, such as cities or where building levees or dikes would interfere with other intersects such as existing buildings, historical architecture, or commercial use of embankments. So mo ni siya flood walls. So ang standard height ani niya for residential is 4 feet or 1 meter pataas. So napoy uban nga ginapatasan nila like dool siya sa sea or dool sa river para ma-prevent niya ang flooding. or overflowing of water from the river or sea. So channels. Flood control channels are engineered, natural, or man-made channels with the specific intent of controlling floodwaters. These types of channels are engineered to a specific flood carrying capacity and have typically been concrete, trapezoidal, or rectangular flumes. So as you can see, sa mga picture na to, mo na siya mga channels. So ang ginabuhatan nila, gina-divert nila ang floodwater pabalik sa ilang starting point. So starting point meaning sa mga rivers or sea. So flood control reservoir. A flood control reservoir protects valuable developments on the downstream floodplain by storing floodwaters and releasing them at a rate that will reduce the downstream damage, so allowing the people downstream to cope with the floodwater or to clean. The water surface level of the flood pool behind the dam can fluctuate considerably during the occurrence of a large magnitude flood, causing the inundation of trees, low vegetation, and water-based recreation facilities located in those areas of the flood pool area that are normally well above the water level. The amount of damage that will occur in the upper levels of flood storage area will depend on the depth and duration of inundation that occurs. So inundation classmates is overwhelming amount of water or overwhelming amount of rain. So man siya flood control reservoir. So gina same siya sa flow through dams nga gina restrict niya ang amount of flow nga mogawas siya ha. So controlling the flood water. So levee, a levee, dike or embankment, flood bank or stop bank is an elongated naturally occurring ridge or artificially constructed field or wall that regulates water levels. It is usually earthen and often parallel to the course of a river in its floodplain or along low-lying coastlines. So kaning floodplain sa river classmates is mura na siya goan. Muna siya tong pag mo-overflow ang river, dito mo ato ang tubig. So mura na siya, patag lang na siya. So mo na siya. Example sa levee. So at the right, you can see nga kuan lang siya, natural lang siya pagkabuhat. Sa left is concrete and stones na siya. So weirs, a wall-like structure over which water can tumble and which is used to raise the level of small water course such as a stream. A weir can also be used to hold back water, which can be released by opening a sluice gate in the weir. This design is very similar to a dam, but is not used to generate any energy from the flowing water. So kaning weir classmates is ginapataas niya ginapagamyan niya ang flow nga mugawas sa iya ha. So example na sa left is rectangular weir. As you can see, ma-restrict ang tubig since ang mugawas lang ang tubig siya kay nalang sa tunga niya katong sa kilid kay mag-stock up lang siya dito. So sa right side naman is V-notch weir or sipility weir nga makita niyo gamay gid ang mugawas niya nga tubig. So flood or stop gates. Floodgates, also called stop gates, are adjustable gates used to control water flow in flood barriers, reservoir, rivers, stream, or levee systems. They may be designed to set spillway crest high in dams, to adjust flow rates in sluices and canals, or they may be designed to stop water flow entirely as part of a levee or storm surge system. So muna siya ang picture. So pag sa left is vertical gate lang siya. So pagbaba na ma-stop gate ang flow. Tapos sa right side is drum gate. So mura na siya weir ang drum gate. So dili siya ma-entirely stop ang flow pero mugamay ang flow nga mugawa sa iya ha. So flood control structures are integral to development priorities. Flood control structures are designed to protect coastal and riverbank areas, including urban and agricultural communities, homes, and other economically valuable areas, and the people located within them. So these structures are used to divert flows of water by redirecting rivers, slowing natural changes in embankments and coastlines, or preventing inundation of vulnerable coastlines or floodplains. So inundation para sa ganina is excess rain or excess water nga naga-overflow. So but flood control structures do not completely eliminate the risk. So flooding may occur if the design water levels are exceeded. If poorly designed, constructed, operated, or maintained, these structures can increase risk by providing a false sense of security and encouraging settlements or economic activity in hazard-prone areas. Nevertheless, many development programs rely on these structures to maintain program objectives, including continued food and water supplies, economic activity, and protection from storms and floods. So climate stressors can significantly impact flood control structures and their services. Flood control structures are often designed to last several decades. So according to my research, maabot siya mga 100 to 150 years. And several climate stressors affect the efficacy and durability of flood control structures, including changes in precipitation, sea levels, extreme events, and resulting storm surges. So, ang climate change dahil kay as you can see ginamelt niya ang ice sa Antarctica, therefore yan resulting in increased height in water level or sea level. Sa top ang initial design sa isa ka flood control structures kay dili niya kaya ma-withstand ang increase in water level, increase in pressure. So therefore kailangan mag-adapt, kailangan i-improve ang flood control structures. So pwede siya dungagan og height, pwede siya i-reinforce pa og maayo, and many more. So for example, increase in the intensity and frequency of floods could overwhelm these structures, causing them to fail. These stressors will grow in importance as climate change continues to alter their intensity, variability, and accompanying hazard potential. So muna siya examples of potential climate change impacts of flood control structures and services. So precipitation change. So muna siya tong naka-change ang ulan, naka-change ang water level, naka-change ang kadagan sa ulan dahil. So falling na siya, falling water. Failure of existing flood control structures due to increased flooding from increased precipitation. So weakened embankments or inefficient impervious core due to erosion and liquefaction from recurring intense flooding. So liquefaction mo ni siya tong muhumok ang yuta due to excess water. So sea level rise mo ni siya tong ganina tong sa climate change gyapon. Overflowing of older structures built to standards that do not integrate sea level rise. So muna siya kung gina-explain o ganina nga di na niya ma-withstand ang changes due to climate change. So weakening of flood control structures due to land subsidence and erosion combined with sea level rise. So inundation of structures in low-lying lands due to failure of flood control structures. And storm surge, overpowering of structures due to increased heights of waves, tides, and surges. So din niya makaya ang increased force nga ang gidesign siya is the previous force nga makaya niya. So weakened or damaged structures, cracks in critical junctures due to repeated storm surge. So kailangan nimo siya i-account ang possibility nga mag-storm, mag-overflow, mag-flood para makaya sa structure. So extreme events, damage to and destruction of flood control structures due to sudden freeze-thaw cycle or the combined forces of cascading events such as cyclones, snowmelt, and heavy precipitation. Breaches of structures leading to temporary and permanent inundation. So these are my references, and thank you and God bless. Keep safe. Yes.